Hello everyone. In this video we are going to discuss about chemical engineering GATE 2020 chemical reaction engineering questions with solution. GATE 2020 question paper and the answer key link is available in my description box. You can download it. Question number 49. An exothermic aqueous phase irreversible first order reaction Y gives Z is carried out in an ideal continuous stirred tank reactor, that is CSTR, operated adiabatically at steady state. So that is adiabatic CSTR. Rate of consumption of capital Y in mole per liter minute is given by minus Ry is equal to 10 to the power of 9 e power minus 6500 divided by T into C1, where minus Ry is equal to rate of consumption of capital Y in mole per liter minute. So here T is the temperature of the reaction mixture in Kelvin. Cy is nothing but concentration of Y in mole per liter. Reactant Y is fed at 50 degrees Celsius. Temperature is equal to 50 degrees Celsius. This is converted into Kelvin, 323 Kelvin. Its inlet concentration is 1 mole per liter. Inlet concentration means that is Cy0. And its volumetric flow rate is 1 liter per minute. Volumetric flow rate is denoted as V0. In addition, use the following data and assumptions. Heat of the reaction minus 42,000 joule per mole. Specific heat capacity of the reaction mixture is equal to 4.2 joule per gram Kelvin. Density of the reaction mixture 1000 gram per liter. Heat of the reaction, specific heat capacity and density of the reaction mixture do not vary with temperature. Shaft work is negligible. If the conversion of Y at the exit of the reactor is 90%, it is denoted as XY is equal to 90% means 0.9. The volume of the CSTR is objective of this question to determine the volume of the CSTR in liter. After calculating the volume of the CSTR value, we have to round up the result to 2 decimal places. Data. Reaction capital Y gives Z. Rate of consumption of Y minus Ry is equal to 10 to the power of 9 e power minus 6500 divided by T into C1. Cy is equal to concentration of Y in mole per liter. T is the temperature of the reaction mixture in Kelvin. Feed temperature is given 50 degrees Celsius. So this is denoted as T1, that is equal to 323 Kelvin. Initial concentration Cy0 1 mole per liter. Volumetric flow rate V0 is equal to 1 liter per minute. Standard heat of reaction minus delta H reaction is equal to 42,000 joule per mole, or delta H reaction is equal to minus 42,000 joule per mole. Cp is equal to 4.2 joule per gram Kelvin. Density is equal to 1000 gram per liter. XA is equal to 0.9. Objective of this problem is to determine the volume of the CSTR, that is VCSTR in liter. Solution part, this is adiabatic CSTR. XA is equal to Cp into delta T divided by minus delta H reaction. So delta T is equal to T2 minus T1. So Cp into T2 minus T1 divided by minus delta H reaction. So here delta H reaction is equal to minus 42,000 joule per mole. So here delta H reaction in terms of joule per mole. This is converted into joule per gram. How? So here delta H reaction multiply with concentration Cy0 divided with density rho. So we could check whether it is right or wrong. So here delta H reaction is a joule per mole, concentration is a mole per liter. So divided by density gram per liter. This is goes to numerator liter per gram. So here moles are cancelled. Liters are cancelled. Finally we get joule per gram. So this is the standard heat of reaction, joule per gram. Okay. So this is a conversion from joule per mole to joule per gram. So what is a delta H reaction here? Delta H reaction value minus 42 joule per gram. Okay. So minus delta H reaction means that is plus 42 joule per gram. Are you clear? Okay. So adiabatic CSTR XA is equal to Cp into T2 minus T1 divided by minus delta H reaction. So here the Cp value 4.2, T2 minus T1, T2 is unknown, we are going to calculate. So the T1 values are 323 divided by minus delta H reaction means this is taken as positive value 42. So the XA value already given, XA or XY, that is equal to 0.9. So here the unknown is a T2. So by using this expression, so calculate the T2 value. So T2 is equal to 332 Kelvin. After rearranging this expression, finally we get T2 value 332 Kelvin. So rate of consumption minus Ry is equal to 10 to the power of 9 e power minus 6500 divided by T into Cy. So what is the general equation? Minus Ry is equal to K into Cy. Compare these two expressions. What is the K here? So the K value 10 to the power of 9 e power minus 6500 divided by T. That is equal to K. So I repeat this and this sentence here. Minus Ry is equal to 10 to the power of 9 e power minus 6500 divided by T into Cy. So the general equation minus Ry is equal to K into Cy. So to compare these two equations, from these K is equal to, so what is this value? 10 to the power of 9 e power minus 6500 divided by T. So here 10 to the power of 9 e power minus 6500 divided by the T value, this is T is equal to T2. So the T2 value already calculated value we should take. So the T2 is equal to, so here 332. Am I correct? This is a calculated value. Substitute here. So 332. So after substituting this value, finally we get the K value, that is equal to 3.14. This is rate constant. Yeah. So now we are going to calculate the volume value. That is our objective. So this is a CSTR. Am I correct? So the tau is equal to space time V by V naught, volume divided by volumetric flow rate. That is equal to Ca naught into Xa by minus Ra. Ca naught into Xa by minus Ra is nothing but K into Ce. So here our reaction is a Y gives Z. What is our expression here? Tau is equal to V by V naught is equal to Cy naught into Xy. This is Y now. Y is a reactant. This is Xy divided by K into Cy. So here what is the Ca value? Ca naught into 1 minus Xc. So this is a general equation. So what is the Cy? For our case, Cy is equal to Cy naught into 1 minus Xc. So here find out the Cy value. Cy naught is a 1 into 1 minus Xa is a 0.9. Finally we get final concentration, that is 0.1. So from this we are going to calculate the volume of the CSTR. So V by V naught is equal to Cy naught into Xa by K into Cy. So here unknown is a V is right. So the V naught is a 1. So here Cy naught is a 1, Xa is a 0.9, K is a calculated value 3.14, Cy is a 0.1. Okay, this is calculated value 0.1. Cy is equal to Cy naught into 1 minus Xa. So here the Cy values are known. So after substituting all value, find out the V value 2.866 liter. Okay. So final value V is equal to, so 2.87. So 2.87 liter. So this is the volume of CSTR. Am I correct? So the answer range is given in the question paper. So here 2.4023. So this answer range is given in question answer key is right. So our answer within this range. So 2.87. This is within this value 2.4023. Okay. So this is the answer for our problem. So for further related videos you can like, share and subscribe my channel. Thank you.